Howdy, folks. This is Mr. Primeaux from Marlin High School. This is Geometry Module 3, Investigating Proportionality. We're in Topic 1, Similarity, Lesson 5. Running up the flagpole, more similar triangles. Okay. Learning objective today is from Teek's Geometry 7b, which states, students apply the angle-angle criterion to verify similar triangles and apply proportionality to the corresponding sides to solve problems. All right, so let's get started. How would you measure the height of the ceiling in the classroom? How would you measure the height of a flagpole outside? Now, how would you measure the height of a very tall building? There are ways to do it without actually having to manually measure it. But suppose you're standing outside on a beautiful day and the sky is clear and the sun is blazing. You're looking at your shadow and thinking about geometry. Of course, we all go outside and think about geometry, right? Right. Anyway, what is the measure of the angle formed by you and your shadow? Think about this for a second. A right angle is always formed by you and your shadow because you're standing perpendicular to the ground and the shadow is on the ground. So you're perpendicular to your shadow. Unless, of course, your shadow is cast onto a wall. So this is a hypothetical situation. If you could draw a line segment, draw one connecting the top of your head to the top of your shadow's head. What geometric figure is formed between your body, the floor or the ground, and that line segment you just connected to the top of your head to the top of your shadow's head? What kind of geometric figure is that? Of course, it's a triangle. It's a right triangle, to be quite honest, between the line segment of the body and your ground. All right, so suppose you're outside at different times of the day and the length of your shadow changes due to the sun's position. Does that geometric figure formed by that line, does it change? You think about this for a second. Triangle does kind of change, but your body's always going to make a right angle with your shadow. And so the geometric figure will always be a right triangle. Always. Only the length of the hypotenuse and the length of the leg formed by your shadow will change. Your height doesn't change, just the length of things change. All right, so at times measuring something directly is impossible or just physically undesirable. Don't have a measuring tape long enough to measure an entire building, right? When these times situations arise, indirect measurement, which is a technique uses proportions to calculate measurement, can be implemented. In this activity, you're going to use a mirror and your knowledge of similar triangles to measure objects indirectly. So let's talk about the law of reflection before we get started. You need to know this law of physics that describes the predictable manner in which light travels. An incident ray here is a beam of light that reaches and reflects off a mirror. Let's say there's a mirror here and it reflects off. A reflected ray is a beam of light that bounces off the mirror. Each ray forms an angle with a line perpendicular to the surface. This is a line perpendicular to the surface. One angle is called the angle of incidence. That's the angle between the incident ray and the line perpendicular to the surface. And the other is the angle of reflection, and that's the angle between the line perpendicular to the surface and the reflected ray. The law of reflection states that the measure of the angle of incidence equals the measure of the angle of reflection. And since these two angles here are corresponding and these two angles here are corresponding, these opposite angles here adjacent to the mirror are also congruent. So consider this law might be applied as you solve indirect problems or measurement problems. So grab a partner in the class, a mirror, a tape measure, and a marker, and use the following steps to measure the height of the ceiling in the classroom. Step 1, use a marker and create a dot or a line in the center of the mirror. Step 2, face the wall you'd like to measure and place the mirror between yourself and the wall. Your feet, the mirror, and the base of the wall should all be on the floor. In other words, it should be collinear. Step 3, sorry folks, focus your eyes on the dot. Step 3, focus your eyes on the dot on the mirror and walk backward until you can see the top of the wall at the ceiling on the dot as shown. Step 4, ask your partner to sketch a picture of you, the mirror, and the object. Review the sketch with your partner to decide where to place the right angles and where to locate the sides of the two triangles. Finally, determine which segments in your sketch can easily be measured using tape measure. Describe the locations and record the measurements on your sketch. I can't really tell you. I mean, I could tell you what to measure, but if you want to measure this length here, and I know it's a flagpole, but we're just talking about the wall in the classroom, you don't know this height. You can easily measure this height, and you might be able to measure a few other things, like it's easy to measure anything on the floor. How do we know that the two triangles in your sketch are similar? Triangle 1 with the wall, not the flagpole, and triangle 2 with you. Here's how you know. Since the person and the wall are both perpendicular to the ground, the angles are both right angles. And notice they're marked with the symbols here, okay? Now we just saw from the law of reflection that the angle of incidence and the angle of reflection in the mirror are the same. Thus the two triangles are similar. All right, we're going to use the sketch to write a proportion to calculate the height of the wall. So we can measure the height up to your eyes, and we can measure the distance between your feet and the mirror, or the line on the mirror, or the dot on the mirror. And we can measure the distance between the dot on the mirror and the wall. So let's get that done. Once you get this done, you should be able to use your proportion to determine the actual height of the wall. And I want you to compare your answers with the other groups in this classroom measuring the same object. And what do you notice? You notice some things that might not be, you might find some people that are the same, but compare your answers to the people in other groups. What may have caused differences if you have some? Now switch places with your partner and re-measure the wall. Repeat the same method of indirect measurement and solve the height of the wall again. Once you do this, tell me if the measurements are the same as the first time you did it with you. And despite the measurement differences, does the indirect measurement of the wall produce the same measure? Now, once you finish the lab, I want you to make sure you put all your books away and utilize the remaining time you have in the classroom to work on Mathia. And here's a little tip. Carnegie has actually started something really cool, but I do want to know your grade always improves when you complete workstations in Mathia. Plus, it gives you an entry into a drawing for a $25 Amazon gift card from Carnegie Learning. So, that's the end of the lesson, folks. Be blessed and be a blessing.